so if pressure goes down, like what we're doing in here, what's going to happen to our volume? It goes up because it's an inverse relationship. So let's see. It's just going to do that with the label. Anyway. So there we go. Pressure is going down and our volume's getting bigger. So over here we have the gauge. We talked about our gauges, right? We had a barometer. It measured atmospheric pressure. And what was the other type of gauge that we had? Start with the M. A manometer. It measures the pressure within a contained chamber. So that's what this is. And right now it's probably like negative 22.5, and that's in inches of mercury. So we know what millimeters of mercury are. Same thing, just inches. So when I turn this off, what is it going to do? The balloon's going to shrink again because our pressure is going to go back up. Yeah, it seals it. So there we go. So there's our balloon. So we have shaving cream. What do we know about shaving cream? It's a foam, right? It's a foam. So what do foams generally have in them that will expand? Air, exactly. So when we put our shaving cream in here, what is going to happen to it as we put it in the vacuum? It's going to expand. Its volume increases as pressure decreases.
Boom.
Oh yeah, this is my favorite one. But I don't want it to make a mess because then I have to clean it up. And I'm gonna smell like a man all day. And then, yep, it shrunk again. Because why did it shrink again? Pressure went up, volume of the gas, the air that was in the shaving cream went down. You can smell it. Okay. So we also have some marshmallows. Marshmallows are made of a lot of air, right? Sugar and air. Oh, there it is. I was like, how did this even happen? Okay, so we're going to keep one of them out so we can see its original size here. So what's going to happen to my marshmallows? Yep, they're going to grow because the volume, the air they have inside them, so the volume of the gas is going to increase as the pressure decreases. Oh, there we go. Okay. So when I turn it off here in a minute, what's going to happen to them? They're going to shrink. Are they going to be bigger or smaller than they started off as, or the same size? Bigger? Okay, so let's see. So, looks like they got a little smaller than they started off with, maybe. I don't know. The ones from first period did. They got a lot smaller. But yeah, apparently they told me in first period that that's how they make like the marshmallows for the hot chocolate. They like dehydrate the air of them, I guess. They were telling me, some kid told me that. So yeah, it looks like it could work. It looks like it could be a true fact. Get all the air out of them and shrink them down. So yeah, so here is our Boyle's law, our pressure and volume. We're going to go back here and do different law. So we're going to be doing, what's our law with radius, volume, and temperature. Using that. Charles' law, yes it is. Okay, so we're going over number 9. That was requested. So let's read through number 9. A toy balloon has an internal pressure of 1.05 atmospheres. So when I see 1.05 atmospheres, what am I going to do? I'm going to stop and label it pressure 1, P1, and a volume of 5 liters. So what is my 5 liters? It's going to be V1. So if the temperature where the balloon is released is 200 degrees Celsius, so what's my 200 degrees Celsius? It's T1 and 473 Kelvin. I don't care about Celsius. What will happen to the volume when the balloon rises to an altitude? So we want to know what will happen to the volume. So what are we looking for? V2. When the balloon rises to a pressure of 0.65 atmospheres. So what am I going to label this? What am I labeling this? P2. And temperature is negative 150 degrees Celsius. So what do I label this as? T2. And what is T2 in Kelvin? Let's see. 150 plus 273. So it should be 123 Kelvin. Okay. So I have P's and B's and T's. So what gas law am I going to use? The combined gas law. Okay, so what is the general formula for my combined gas law? So now I just have to plug in my numbers. So I said P1 was 1.05 atmospheres. V1 was 5 liters. T1 was 473 Kelvin. And this is equal to P2, which is 0.65 atmospheres. And V2, which we said, oh, that's what we're looking for. We don't know what it is. Over T2, which is 123 Kelvin. So then I'm going to solve for V2 using my algebra. So what did we get for V2? I think we should get, let's see, 123 times 1.05 times 5 divided by 0.65 times 473. I got 2.1. What did y'all get? Everyone get 0.9? Yeah. Yeah. You got 2.2? 10? Yeah, that's what I got. I got 2.1. So, liters. Okay, so when we do our algebra, we have to cross multiply. So we're going to cross multiply first, and we get 123 times 1.05 times 5. That's going to be equal to V2. I don't have to work these out for y'all if you don't want to. Yeah. Okay, so then when I cross multiply my other side, I get V2 times 0.65 times 473. And so then I have to divide by 0.65 and 473 on both sides because I want to cancel these out and get V2 alone. So I'm going to come over here, divide by 0.65 and 473. I plug that into the calculator and I get a V2 of 2.1. Now And I have to remember my PEMDAS and make sure that I put parentheses around the bottom before I put them into my calculator. Yes. Number 6. Okay, so on number 6, we have 5.36 liters of nitrogen. So I have to stop and label this first. What do I label it as? P1 of nitrogen gas, and it's at 25 degrees Celsius. So I have a number. So what do I need to do? T1. Then I have to change it to Kelvin. So what do I add to it? 273, and I get 248 Kelvin. And oh, another number. What am I going to label this as? P1. So I want to know what would the volume be. So what am I looking for? I'm looking for my V2. At 128 degrees Celsius, so another number, T2. I have to add 273 to get it in Kelvin. And I get 401 Kelvin and 1.5 atmosphere, which is my pressure, my second pressure. Anyone see a problem here with our numbers? They're not all in the same unit, right? Because yesterday we said that we have to have the same units to be able to do these problems. So we have liters for one volume. If we put liters in, we'll get liters out. Okay. We have Kelvin for our temperature, they're in the same. But for our pressure, we have millimeters of mercury and atmospheres. So we have to convert one of them to the other. So I'm going to convert my atmospheres into millimeters of mercury. So I'm going to take my 1.5 atmospheres, and I want millimeters of mercury. I know atmospheres has to go on the bottom. So what's my conversion factor between atmospheres and millimeters of mercury? What's my conversion factor between atmospheres? 1 atmosphere equals 760 millimeters of mercury. I'm going to do 1.5 times 760. And this is 1140 millimeters of mercury. Okay, so I got all my numbers that I need to plug in. So now I have to figure out what I'm going to plug it into. So what gas law am I using? The combined gas law. Because I have P's and V's and T's. So I'm going to have P1 V1 over T1 is equal to P2 V2 over T2. Plug in my P1, that's 733 millimeters of mercury, times V1, which was 5.36 liters, and I'm not going to have room. Divide by T1, 248 Kelvin. This is going to be equal to, let's see, 1140 times our V2, we're looking for it, we don't know it, and divide by our T2, which is 401. And we cross multiply, divide to get V2 alone, and let's see what we should get. Times 401. Okay, we should get 5.57 liters because we put liters in, so we know our units have to be liters for volume. So, does anyone else have any questions about last night's part or any that you've gotten to today?